Hello everyone, welcome to this session. Today we will discuss some main points of chapter 13. The chapter name is Magnetic Effects of Electric Current. So let's get start. You know very well magnetic field, right? Magnetic field, the region surrounding a magnet in which the force of magnet can be detected. It is named as magnetic field. What is magnetic field lines? The magnetic field lines can be explained as imaginary line that graphically represent the magnetic field acting around a magnet. You can see in the picture here, right? This one, this one, right? Field lines around a bar magnet. This is a field of magnetic field line. What is the characteristics of magnetic field lines? You can see here. First, the field lines emerge from North Pole and merge at South Pole. Here you can see, here is the North Pole, here is the South Pole. The field lines emerge from North Pole, this line, this type. Second, inside the magnet, the direction of field lines is from its South Pole to its North Pole. Thus, the magnetic field lines are closed curves. What is the properties of magnetic field lines? First, the tangent drawn to the magnetic field lines gives the direction of the magnetic field. The closeness of or density of field lines is directly proportional to the strength of the field. The field lines emerge from North Pole and merged at the South Pole. Inside the magnet, the direction of field lines is from its South Pole to its North Pole. Magnetic field lines from closed curves. Magnetic field lines never intersect each other. Magnetic field lines never intersect with each other. It is very important points. Now do you know it's always asking in the examination thumb right hand thumb rule. You can see here if a right conductor is held in the right hand in such a way that the thumb points along the direction of the current, then the finger curl in the direction of magnetic field around it. You can see here, right? This is a current, you know very well, or this around earth is what? This is your magnetic field. Now the next, it is very important, right hand thumb rule. Field due to current carrying conductor. When current is passed through a straight current carrying conductor, a magnetic field is produced around it. Current carrying conductor, magnetic field is produced around it. The magnetic field lines are represented in the form of concentric circle around the conductor. You know concentric circle, it has a one center and like this one. Okay, so let's get here also be given here. You can see here is the picture. Some questions asked on the pictures that what is this? Magnetic field due to current through a circular loop. Every point on circular loop will act as a straight conductor. Magnetic field are closer near the conductor, which means the magnetic field is stronger near the periphery of the loop. The next, magnetic field lines move away from each other as we move towards the center of the carrying loop. At the center, the magnetic field lines appear as a straight line. You can see here in the picture, this one. Next, magnetic field lines of the field produced by a current carrying circular loop. You can see here in the picture, right? Next point, field due to a current carrying coil or solenoid. You can see here, field due to a current carrying coil or solenoid. A coil of many circular turns of insulated copper wire. Here you can see what closely in the shape of cylinder is called a solenoid. If you wire what the wire of copper which is insulated closely, the shape of a cylinder is called a solenoid. When current is passes through it, behaves similar to a bar magnet. One end of solenoid behaves as the north pole and another end behaves as the south pole. Now, next, this picture is very important to understand, right? The field The field lines inside the solenoid are in the form of parallel straight lines. The field lines inside the solenoid are in the form of parallel straight lines. This indicates that the field is uniform inside the solenoid. I hope you are understanding this one, right? What is electromagnet? Magnet formed by producing magnetic field. Magnet formed by producing magnetic field inside a solenoid is called a electromagnet. It is temporary magnet that can be easily demagnetized by stopping the flow of electric current in the coil. If you stop the current supply, it becomes demagnetized. If you apply the current, it's become electromagnets. The strength of magnetic field due to current carrying solenoid is proportional to the number of turns in the coil and magnitude of current flowing through the coil. The 2 points are very important, right? The number of turns in the coil and magnitude of current flowing through the coil. Force on current carrying conductor. You can see this one, magnet U shape. Here is a stand. You can see A and B here hanging. So here is the K, here is the battery. You can understand. You have done the experiment in your school. What is this? A current carrying rod. AB experiences a force perpendicular to its length and the magnetic field. This picture shows that AB experiences a force perpendicular to its length and the magnetic field. When an electric conductor is placed in the magnetic field, it experiences a force. The displacement in the conductor is the maximum when the direction of current is at right angle to the direction of magnetic field. Next, it is also very important, Fleming left hand rules. According to these rules, stretch the thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular. If the first fingers point in the direction of magnetic field and the second finger in the direction of current, then the thumb will point in the direction of motion or the force acting on the conductor. You can see in the picture, you can see here. This is a Fleming. Here is the forefinger, here is the thumb, here is the middle finger. You can see. This is the figure we can understand, right? Fleming left hand rule. Electric motor, you can see here how it's formed. It also very important, electric motor. An electric motor is a rotating device that convert electrical energy to mechanical energy. Electric motor convert electrical energy to mechanical energy. It says also points very important to you. You can see here is the picture and you have drawn many times this picture. So what is the principle of the electric motor? An electric motor works on the principle that when a current carrying rectangular coil is placed perpendicular to magnetic field, it experiences a force which rotates it continuously. It experiences a force which rotates it continuously. You understand? Construction of electric motor. You can. It is also very important to should keep in mind. Construction of electric motor. It consists of rectangular coil ABCD of insulated copper wire. The coil is placed perpendicularly between the two poles of magnetic field. The end of the coil are connected to halves P and Q or split string. Split ring act as a commutator which reverses the flow of current in the circuit. We use the commutator. What is its function? It reverses the flow of current in the circuit. The inner side of a split ring are attached to an axle which is free to rotate. Axle which is free to rotate. The external edges of a split ring touch two conducting stationary brushes X and Y. You can see in the picture here. It is X and Y. It is a brush, right? You can see here A, B, C, D, right? It is a simple electric motor figure. The brushes are attached to the battery to complete the circuit. The brushes attached with the battery. You see here, right? This one. I think that here is the brush. It is attached with the battery. Clear? Working of electric motors. It is also very important. I think that this question will be asked. Electric motor. Write about electric motor. Draw this one. It will be asked in the question. Weightage 5 marks. Current in the coil ABCD enter from the source of battery through the conducting brush X and Y, flow back to the battery through brush Y. Current flows through coil A to B, then from C to D. The direction of magnetic field is from north to south. North to south. This is very important point. By Fleming's left hand rule, the force acting on arm AB pushes it downwards. Force acting on arm CD pushes it upwards. Downwards means this one, upward means this one, you know very well. Thus the coil and axle O rotate anti-clockwise. It rotates anti-clockwise. After half rotation, Q touch the brush X, P touch brush Y. Therefore, the current in the coil gets reversed along the path DCBA. Now the current CD flows from D to C and in AB from B to A. How the current flow? The current flow in CD flows from D to C, in AB from B to A. So CD moves downwards, AB moves upwards. What is commutator? You know very well, just I have said, a device that reverses the direction of flow of current through a circuit is called a commutator. Significance of commutator. What is the significance of commutator? In electric motor, the split ring acts as a commutator. The split ring is used to reverse flow of current to make coil rotate in a single direction. Otherwise, in absence of a split of the coil would have rotated half in the clockwise direction and half in anti-clock direction. If a split is absent there, it will be rotate half clockwise or anti-clockwise. So it's not complete the one round. So the commercial motor use, it is also important, right? The use of the commercial motors. Commercial motor, an electromagnet in place of permanent magnet. Second, large number of turns of conducting wire in the carrying coil, and a soft iron core on which the coil is onded. Onded means it is a coil. You can this one. Okay, what can you say? The soft iron core in which the coil is onded plus the coils is called a armature. The soft iron core on which the coil is wound plus the coils is called armature. It is also important point. This enhance the power of motor. What is the function of armature? It's enhance the power of motor, right? Magnetic induction, it is also very important. When a conductor means coil, is placed in the changing magnetic field, a potential difference is induced in it, which steps up an induced electric current in the circuit. This phenomenon is called electromagnetic induction. It is also very important term, electromagnetic induction. The induced current is found to be highest when the direction of motion of the coil is at the right angles to the magnetic field. I hope up to this one you have understand electromagnetic induction is what. Fleming's right hand rules, you know. Here is this picture. You understand this one very well as I know. Okay. According to this rule, stretch the thumb. You can see here it is a thumb very well. It is a thumb. Forefinger, this is a forefinger, and middle finger, this one is the middle finger, right? Can you like this one? This one. Okay. Uh, right hand, so they are perpendicular to each other. If the forefinger indicates the direction of magnetic field and the thumb shows the direction of motion of the conductor, then the middle finger will show the direction of induced current. It is also very important, Fleming's right hand rule. Two rules there, na? Fleming's left hand rule and right hand rules. Both of them, one will be asked from you. Okay, so it is a 1 minute revision. You can revise it. I hope you will solve so many questions asked from this chapter. Thank you. Have a nice day to all of you, my dear Indian future.